Okay, today we're going to be looking at the Lesson 13 practice problems. Remember to pause these and try them on your own, and then start it again to check your solution. So there's two approaches to number one to identify a solution to this system. We could test each XY coordinate pair and see which X and which Y works for both equations. That might be, 4 different problems testing them. That might be a little bit more work. So we're going to use the system of substitution, the method of substitution to solve. In order to do that, I really want to isolate one of the variables so that I can take what it's equal to and plug it back into the other equation. So here I can easily see that if I move the y over, I can isolate the x, and now it's ready to use for substitution. So I'm going to take that second equation. I'm going to get a big open parentheses here for the x, so I can plug one into the other. So I notice that x is equal to y minus 7, so I can plug the y minus 7 in. Now I'm just solving an equation of one variable. I'm going to multiply negative 4 times y, negative 4 times negative 28. Oh, times negative 7. I gave you the answer. It's positive 28. So when you distribute like that, did you remember to do the second distribution? Did you get positive 28? Now we're able to combine like terms. The y's go with the y's. Negative 4y plus 3y is going to make negative 1y. Remember that you don't have to put the 1 there. It can be invisible. The 28 is still there on the left, and the 23 is still there on the right of the equal sign. We're now going to move the constant over by subtracting 28 to both sides. That cancels this out. 23 minus 28 is negative 5. My final step is to divide both sides by negative 1, and dividing by negative 1 is going to give me positive 5. Now this is only half an answer. If I look up at my answer choices, I'm leaning towards B because that has a y of 5, but let's go check the x just to be safe. If I plug in the 5 that I just got for y, 5 minus 2, I keep saying the answer, 5 minus 7 is negative 2. So again, I can now see my full xy coordinate pair, x, comma, y, and my correct solution is B. So do you like solving by substitution, this method, or do you just want to plug in the xy coordinate pairs? It's up to you. You would still arrive at the same solution. All right, on the next one, someone has already done the work for us. Lynn has solved this system of equations, the same method we just did. They already isolated right here. The y variable is by itself. Taking everything that y is equal to right here and plugging it in for y. Then we go to watch the next step, the distribution. Negative 5 times 4 is negative 20. Negative 5 times negative 1, oops, this should have been a positive. So first of all, just in glancing at the work, I'm already noticing that I think that there's an error. So to check to see if Lynn's solution is correct, what if I make an error like that when solving? How could I go back and check my work? So for part A, we're going to take the equation 6x minus 5y equals 34, and we're going to test the solution that we got. We got negative 36, or we didn't, Lynn did, and we got 58. And if this is correct, it should get 34 on that left side. Well, this makes negative 216. Wow, that's really big. And then grab a calculator, 5 times 58, I think that's 290. 5 times 58. That's negative 290. Well, let me tell you, this is not 34. Okay, so also by checking our work, plugging back into the equation, we can see that no, Lynn's solution does not make both equations true. So this is just showing us a way to check our work. once we get a solution to make sure it's right. If your answer to the previous question is no, find and explain the mistake. And so we noticed that Lynn forgot that negative times a negative equals a positive in the second distribution. Now remember that these responses on IL Classroom, this is your own words, you explaining in your own words how you would describe the error. It does not need to be my exact words. Put it into your own words. Next is just some practice solving systems with substitution. Notice that the X is already isolated and that the Y is already isolated. Please pause this video, go practice this substitution method from middle school. Do you recall how to do this? Okay, let's check your work. So I'm taking that first equation and I'm plugging in that X equals 4 right here for X. Now I'm subtracting 8 from both sides. Now I'm dividing 4 to both sides. And I got -3. -3 is just half my answer. I need the X as well with the Y. Well, the X is 4. We already had it to start with. So my final coordinate pair answer should be 4, -3. How'd you do? All right, go pause the video and try the second one. This time we were given Y as the isolated variable. So make a big opening where the Y is. Y is equal to all of this. So go plug in all of that for Y. We're going to leave this 2x alone in front. We're going to distribute this -3. Distribute this -3 again. We're going to combine like terms. 2x's minus 18x's. We're going to add 33 to both sides. We're going to get -16x on the left is equal to 40 on the right. Now this is looking like it's going to come out to a decimal, which is okay. It's not ideal, but it's what happens sometimes. 40 divided by 16 gives us -2.5. Why is it negative? Because a positive divided by a negative is a negative. Okay, that's just my X. I now need to go plug back in to get my Y. All right, now I'm going to plug in the -2.5 that I got for X. Grab a calculator and do that. And I got -15 plus 11, which is just -4. So here's my XY coordinate pair. X is -2.5, Y is -4, and I put that together for my final answer. -2.5, comma, -4. So how'd you do on those systems of substitution when a variable was already isolated? Tyler and Han are trying to solve this system by substitution. Tyler's first step is to isolate the X in the first equation. So notice he put the -3Y's on the other side. Han's first step to try to isolate 3Y is to get 3Y equals -5 minus X. Show both first steps can be used to solve the system that will get the same equation. And so basically, both of these students are doing the right method, but one is choosing to solve for the x and one is choosing to solve for the y. So if I'm going with x plus 3y equals -5, one student decided to do -3y's to both sides and to isolate the x. One student chose to move the x's in order to isolate the y's. Both are valid steps because I need an isolated variable to plug in. Here's an isolated y, here's an isolated x. But if I'm looking at this, which one would I choose to use to solve? Well, this is ugly. This has fractions in it. I am not going to use this method if I can help it because I don't want to have to plug in weird fractions. So we're going to solve it using Tyler's method. We've already got x isolated, so let's go plug in that x since it's not a fraction and going to give us a little bit easier computations than the other one. Okay, so we're going to take the other equation, 9x plus 3y equals 3. We're going to take what we got for x, we're going to distribute, and then we're going to add the constant. We're going to get -27 equals 48. Sorry, I did something wrong here with I forgot the plus 3y's, you guys. Hang on. Right here, there was another plus 3y that I forgot. So let me just add that back in. Okay, now we're plusing 45 over there. We got our 48. And then where does this come from? -27 plus 3y. When I combine those like terms, I'm going to get -24. When I divide both sides by -24, I'm going to get -2. Now I take this -2 and plug it back into either equation in order to solve for x. And we get -5 plus 6, and so x is equal to 1. Now, if I solved it using the other student's method, I would still get this same solution. It's just that it used a lot of fractions, but it would still yield the same equation. So if that's the one you chose, you totally could have done that as well and still should match. But there's my solution, 1, -2. All right, the dot plot shows the distribution of length in centimeters of 25 shark teeth. Ooh, that's kind of freaky. This is for an extinct species of shark, and then the length for a closely related that is still living. So it's giving us the mean and the standard deviation. Remember that the mean is showing us a measure of center, and the standard deviation is showing us how spread out our data is from that middle or that center. The second one, the mean, is a smaller number. That's the living species, but the standard deviation is smaller, so less spread out. Compare the two dot plots using the shape of the distribution, the measures of center. Use the situation to come up with an explanation. So we would say the distributions have similar shape. Do you remember what kind of shape this looks like? It was called bell-shaped or normal. And then we could also say something like the teeth from the extinct are larger and it shows more variability than the teeth from the current living one. The teeth from the extinct shark are larger and have a bigger variability and show greater variability. Again, we're just trying to keep the chapter 1, the unit 1 stuff fresh in our mind so we don't forget it all, talking about the shape of distributions, the measures of center, and the measures of variability that we studied. All right, Kieran buys supplies for his greenhouse. He buys F bags of fertilizer and P packages of soil. You're going to read this scenario, 5 per fertilizer, 2 per soil, and this equation they gave you. And so if he solved this equation for P, which one would match? Pause the video and test it yourself. All right, now let's check your answer. So just looking at this work to start, do you see any that look like they could match so far? Well, this one is close, but it's got the wrong signs. It's got a -90 and a +5, so it's like the fake out one, be careful. It wants us to do like the warm-up from our recent lesson where we keep simplifying this into 45, 90 divided by 2, and then 5 divided by 2, 5 halves, F, is also known as 2.5F. It should be this one. What do you think? Is that what you got? Elena wants to find the slope and y-intercept of this graph. She decides to put the equation in slope-intercept form first. Here's her work. So where did this negative go? We minus the 25x, and then we divided by 20. I think she forgot that negative. So she got that the slope is -5/4 and the y-intercept is 0.5. So in the second equation, so forgot the negative, or in the second equation, she forgot to bring down the negative. So then what are the actual slope and y-intercept of the line? So we're going to take off from the step where she made the error. So copying her work, but adding in the negative, I now should have been dividing by a -20 to everything. So we still get that 100 divided by 20 is 5, but it's supposed to be -5. And we still get 5/4 as the reduced slope, but it's supposed to be a positive 5/4. So now what are the slope and y-intercept? Slope is this number in front of the x, and y-intercept is this value back here. So we would say slope is 5/4, y-intercept, known as our b, is 0, -5. How'd you do? Find the x and y intercepts of the graph of each equation. So this is where to get the x-intercept, the y is 0. For the y-intercept, the x is 0. This is going to be a lot of plugging in here. So I'm actually just going to put the solutions on here, but I'm going to want to see your work on these. But a couple of them are not as hard as they sound. So here, this is already an mx plus b format. And so this one already has a y-intercept staring at us. It's the 0, 10. But to get the x-intercept, we have to plug in 0 for y. Now I'm going to add 2 x's to both sides. And I get that x is equal to 5. So I write my intercept in intercept form of 5, 0. My y-intercept is over here as 0, 10. So here's the x-intercept. Here's the y-intercept of number A. All right, next we're plugging in the opposites to get it. So for the x-intercept, the y is 0, so we're just going to solve the x. For the y-intercept, the x is 0. You're just going to solve the y. Keep going, see what you get. For the x-intercept, the y is 0. For the y-intercept, the x is 0. Keep solving, keep solving. For the x-intercept, this y zeroes out. For the y-intercept, that x zeroes out. This one I'm going to need to minus the 12 y's to both sides and divide by negative 12. And you're going to want to do a reduced fraction. And then our x-intercept is 2. So how do I write these answers? I have to write the x-intercept as 2, 0, and the y-intercept is 0, negative 3. Okay, what about B and C for you to check your solutions? B should be 2, 0, and 0, 4.5. And then C is 7 1/3 or 22 thirds. If you reduce that 44 over 6. And then 0, negative 22. Make sure you show full work for those over here solving. How are you doing on x and y intercepts? Okay, Andre is buying a pound of snacks. Here's how much apricots are. Here's how much bananas are. He buys a total of 5 pounds and dried bananas and spends a total of $24.50. So this is where we want to keep money with money. So 6 per B, 4 per, bananas are 4 per B, 6 per A, and keep the money with the money with the money. So which equation has the 6, the 4, and the $24.50 together? Well, it could be this one. None of the other ones have it, so I guess that's probably our answer. And then the other thing that makes the other equation is that we have a total of 5 pounds of everything, apricots and dried bananas. So that's where this other equation comes from for the total of 5 pounds. There's our 2 equations. How'd you do? That means that B is our answer. Finally, here are 2 equations. Using graphing technology, find a point that is a solution to equation 1, but not to 2. So let's go graph this. 1, 2, 3, 4, 5, 6, 7, 8. And then up 3 over 1 or down 1, 2, 3, back 1, 1, 2, 3, back 1. Okay, so this line is this line. Okay, and then the second line, let's go 2x minus y equals -6 minus the x's. Obviously, you could be doing this on Desmos. It said to use graphing technology. You don't have to hand graph this yet, but we should know how to hand graph from middle school, right? All right, so this one's touching at 6 and going down. Let's use a different color. Touching at, no, different color than that. Touching at 6, down to over 1, down to over 1, down to over 1. So this would be the equation of this line. So using graphing technology, find a point that's a solution to equation 1 but not equation 2. We would just go look on Desmos for a point like this on equation 1. Well, that's at back 2, up 2. And then find a point that is a solution to equation 2 but not equation 1. So we could like use this dot right here, 2, 2. Graph the two equations and find a point that is a solution to both. So we can see that somewhere up here it touches. Okay, well, where exactly does that touch? If I'm using graphing technology, I can tell. If I'm not using graphing technology and it ran off my graph like that, I'm going to want to do the algebra to make sure I did it right. And so we're going to distribute that -1 and make it -3x's minus 8. 2 minus 3x's, when I combine like terms, makes -1x. I'm going to add this 8 to the other sides and get 2. Divide by -1. I get x equals -2. Then I'm going to plug back into the other equation, y equals 3x plus 8. And so y equals 2. Okay, well, if that's the case, my line is way off. So hang on. 1, 2, 3, 4, 5, 6, 7, 8. This first line looks great. It's got to be my second line. 2x minus y equals -6 minus the 2x is okay. Divided by -1. Oh, I should have had a positive slope on that. Sorry, guys. Sorry. I did a negative slope, and this should have been a positive slope. Okay, so this is going to go down to back 1, down to back 1. And so here's the correct line. And that's exactly why we do the algebra. And their point of intersection is at -2, 2, like the algebra told us. Okay, we're at the end of the practice problems.